Tony Bemus, talking about network packet sniffing. No, excuse me. Network packet sniffing with TCPDUMP and Wireshark. And with that, who wants to go first?
I will start.
Why did I say network packet sniffing?
Network packet sniffing.
5 times fast.
Okay. So some months we have a guy get up here and give a presentation. He brings a great big slideshow with him, and we watch him go through his 30 or 40 slides. That's not happening tonight.
Thank you.
Tony and I talked about this. I have a slide presentation. It's got one slide. Tony doesn't have any. And the only reason I have one slide is because I've got a diagram I wanted to show you to clarify some stuff. But mostly this is kind of a hands-on, let us show you what you can do, sniffing packets and that kind of thing. Before I get started, how many people have used TCPDUMP? Wow, so like more than half of you. How many feel confident, comfortable with it? A couple, good.
I could go through the main
How many
pages
folks have to
again.
go on to Google every time that they want to try and do something with TCPDUMP?
For me, it's the man page.
Yeah, the man page works
That's
for
because
me.
it's there, right? It's,
Yep.
it's there. How about Wireshark? Because we're also going to cover that.
I played with it.
Wireshark rocks, doesn't it? Yeah, but sometimes you gotta go down to the command line and use what you got. Let me just get that out of the way. Let me talk a little bit. Let's see, somewhere here I have I just got a MacBook and I'm still trying to figure out how to use the thing.
It's supposed to be so simple.
Lots of figures, but I'm getting there. Let me see, I gotta bring up my, all right, where'd the icon go for my, there it is, okay, good, my VPN is still up. Let's see, there's just a whole bunch of points I want to cover. TCPDUMP is used for packet sniffing, as Craig said. That's what we're going to talk about tonight. By packet sniffing, we mean watching the traffic between two endpoints on a network. That's pretty much what you have to do now. If you're in a network that's got a hub, and you tap into that network, and everything's connected through a hub, not a switch, you get to watch all the traffic on the whole network. But for the most part, you're watching traffic between two endpoints. At least that's what I use it for. You can see broadcast traffic as well. Broadcast traffic would be seen by all the nodes on the network, at least within that collision domain. But TCPDUMP is used to tap into a network stream and watch the packets flow by. So I'm going to do that real quickly here. Something that's important, though, with TCPDUMP is to know which network interface you're going to watch. So let's see. What is the interface? EN0, is that my Ethernet interface? No, actually I want my wireless. What is my wireless interface on this thing?
EN0.
No.
Does that have an IP address?
192.168.1.1.
1.142, okay, good. So EN0, okay. So I'm just gonna, before we get too far into the details, I'm just gonna do a quick network trace. -I, EN0. Yeah, let's just do that. Is that not the name of the interface?
That wouldn't be the name of the command.
You forgot TCPDUMP.
Yeah.
Sorry.
There you go.
Okay, so we're going to do that. All right, it's running. Now all the traffic flowing on the network between my laptop and the world is flowing by. So we're going to make that a little wider so you can see a little bit better. Right? And then if I bring up something like, let's go to CNN. Okay, so now you can see tons of traffic flowing, right? As it's drawing the pages, lots of traffic, way more than you could possibly care to look at. Okay, that's a simple trace of traffic. It's still challenging with a small screen.
Yeah.
Just look at the lower glass up. Anyway, that's the traffic flowing between my laptop and the world, all right? Not too much to look at. If, let's see. Let me talk to you for just a minute about why you might want to do this, why you might want to look at network traffic. I broke out of it, you can see we saw 7,200 packets. Captured 56, 62 of them. I didn't have a filter specified, I'm not sure what the difference is there. Years ago, there's a reason why I'm showing TCPDUMP and why Tony's showing Wireshark. That is because I'm the old guy and I'm used to the command line tools. Tony's the young guy, he gets to do the new fancy stuff. Years ago, around 2000, 2001, I was heavily working on LTSP, my project at the time. And I was having a problem with TFTP. We were network booting some thin clients, and I was having a problem with TFTP, which is a trivial file transfer protocol. It's kind of like FTP, only not really. It's really just for reaching out to a server and grabbing a file and pulling it down. I had a buggy network card. It was an RTL 8139 network card. The driver was bad on it, and I was troubleshooting, trying to figure out what was going on. So I thought, oh, I better watch the network. So I grabbed TCPDUMP, and I put a hub in between the server and the client, and I watched the traffic flowing by. And man, I did it the hard way. I did TCPDUMP -IEN0.
Stuck or something.
-X, because I needed to see it in hex. Then, let's see, what's the, I forgot what the, port 69 for TFTP. So I did a filter, port 69, and I watched the traffic. I just basically did that, and I watched the traffic flow by, and I actually wrote it out to a file. And then I did something fun. I needed to see really what was taking place in that. And if you do this, it's going to capture. Like let's do that on port 80. I go out to what's that website that's Mud.org is a good one. Okay. See, when I do that, everything's coming up in hex.
Yeah.
Right, there's a lot of traffic there. That's probably an image that's downloading at that point, but you can see further back.
I'm not seeing that.
There was some good old HTTP stuff, some HTML. So anyway, you can see byte after byte after byte. I captured all that, and I wanted to figure out how TFTP worked. I needed to figure it out because I had to have this thing working. So I went to the RFC. How many of you guys are comfortable or familiar with the RFCs? And they basically explain the protocols and the layouts for all the network stuff you could ever want to do. So that's it. This is what I did. It took me 2 days to go through this. And the search page, look for TFTP, that. And we'll just get into the very first one. The RFC lays out exactly how TFTP works. So I read the RFC, figured out all the what it was. Let's see, you can see some of the byte layout. There's, you know, explains 2 bytes for the opcode. There's strings. There's the whole thing. TFTP works by fetching blocks of data, like 512 byte blocks of data. So I went through that whole thing. I basically took apart that entire conversation between the client and the server using TCPDUMP. This is a case where I had to solve a problem. I used TCPDUMP like that in hex to do that. The very next day, I learned about Wireshark. After fetching those packets and taking it apart, I mean, it took me 2 solid days. I did solve the problem. We found that there was a bug in the RTL 8139 driver. Another guy that was working on that out in Boston, he and I figured out there was a. This was not the Linux driver for the RTL 8139. This was a Etherboot driver, which is used for boot ROM. And we figured out there was a bug. The 8139 chip has a 14-byte circular buffer, and it was wrapping on itself. And, I mean, the circular buffer is supposed to wrap, but it was
Stepping on itself.
Yeah, basically stepping on itself. We solved the problem because we were able to watch what was going on and take care of it. Let me talk about this command line just for a second here. You know I'm running. You can see this, okay, can't you? TCPDUMP -I for the interface, -X because I want to look at the packets in hex. I can also do a -A, which would show me the packets in ASCII, which is great if you're looking like at web pages and stuff. And then there's a place to put a filter. And I put a real simple filter. I said port 80. So that's just HTTP traffic. I could have said a specific a machine. I could have said where the destination host is www. And port 80. So that would just show me HTTP traffic for www.mug.org. I could have said, instead of destination, I could have said source, SRC. So I could have watched traffic for a source. I could have said another port. There's a fairly complex language for specifying the filters.
Does it allow regex?
No, it doesn't.
Is it smart enough to know that mug.org and mug.org are the same subdomain?
That's just a DNS thing.
Okay.
If your DNS is set up correctly, it's just going to resolve whatever you put there for the host name
That'd be
to an IP address, and that's what it's going to search. Right? That's what it's going to look.
You can do an IP there though too, right?
Yes, you can do an IP address there. You can do deep stuff, like you could say where the proto is TCP, and where a certain flag in the TCP IP header is, has some value. So you can look like for ACK packets or SYN packets or reset packets or whatever kind of packets you want. It's fairly involved. That's all given to us by the PCAP library, which TCPDUMP is built around. And I'm pointing that out because Wireshark is also built around that. So whatever you use for filtering, like we're doing here, we can use the same filters in Wireshark. So it's really handy. So whatever you learn by doing TCPDUMP, you can carry over to Wireshark. And the filters will really come in handy because it'll cut way down on the volume of traffic that you're getting. So why am I talking about this? Wireshark, as Tony's going to show, is great. You run it on your laptop or your PC, and it's great for watching the traffic that's local to your laptop. But what if you have a server configuration? Let's see, how do I get to it on this thing?
Next over. Figure loading.
There it is. I'm involved in a lot of situations where I'm not trying to sniff network connections that are local to my desktop. I do a lot of server-based stuff, and I do a lot of stuff between like thin clients and servers where I'm not at that thin client, or stuff between customer desktop machines and their servers where I'm not there. I could be hundreds of miles away from there. It's a situation kind of like this, where this is the client, it's like a web browser typically. The link is encrypted through SSL to the server. Now I run my servers, I'm running HA proxy on my servers to terminate my SSL connection. So I've got HA proxy handling the SSL part of it. The connection between HA proxy and Apache is not encrypted. It's running on, they're running on the same server, it's just running on the loopback interface. So I can get in there and I can snoop on the traffic between HA proxy and Apache, and I can watch what's going on. That machine might be 300 miles away from me, but it doesn't matter because TCPDUMP is a command line utility. So I can log in, I can SSH into that server, and I can bring up TCPDUMP and on -ILO, which is the 127.0.0.1 of the loopback interface, and I can watch the traffic. And I can go through the process of watching it in hex if I want, or watch it in ASCII if I want. I can see the traffic flow. But what's really cool is I can just capture that packet trace to a file, download it to my desktop, and run Wireshark and look at that packet trace. And that'll give me all the nice analyzing tools that Tony's going to show you. But we can try a little bit of that. Figure out how to get out of that. There we go. Oh. That out of the way. So I'm going to log in. I've got a server out in the cloud there. As long as my VPN is still up. Let's try this. So this is a server. This is a Linux server. Over in Southfield. I SSH into that, and I can run th0-w/temp/TCPDUMP PCAP. That's where I'm going to put the file. Then there's an important option that I want to get, -S0, and what that is, -S is the snap length. That tells it how many bytes to grab. By default, I think it gets about 64 bytes. And I really want to get all the bytes that go across the network. And then I'm going to put my filter in. So let's see, in this case I want, let's do that. Let's capture port 443. Go to my website. This is that website that I'm connected up to. If I put in my username and password, break out. I grabbed 134 packets.
password?
Well, it will, yes.
Well, because it was an HTTPS connection, it's encrypted.
There's nothing.
So if it's encrypted, how are you gonna be able to read it?
That's exactly, I want to show you that you can't read it because it's encrypted. Here's the whole packet stream, 134 packets. Okay. You see that it's TLS, that's SSL, right? If I click on one of those packets and try to look at it, in fact, if I look at it this way, it's just, I mean, it's all encrypted. I mean, it looks like garbage, but it's just, you know, encrypted stuff, so you can't see it. Okay, that was this one. No. That was this one. You know what I'm gonna do? How do I tell this thing to be on a different window?
Control right arrow? That's not control, it's the
Command right arrow?
thing, so.
No. Sherrod, you're using that. How do I?
Wait, what are you trying to do?
I want to put, see, I've got two workspaces.
Yeah.
You want to type?
I want to put this thing over on that workspace.
Yeah.
There we go. There we go. Okay. Okay, so when I did the TCPDUMP command to capture that packet trace, I connected right here. I watched that interface right there, and it's all encrypted. So there's really nothing much to see, just an encrypted session.
Question. That TCP dump is running from your HA proxy computer? Or from the
It's running on the computer running HA proxy. It's running on the encrypted side of HA proxy. You guys know what HA proxy is? It's, yeah, I use it because I have one certificate for SSL, and I have multiple machines in the back behind it, and I want to send different requests to different machines. So HA proxy is what I hit with my SSL cert, or with my encrypted connection. We're going to have a presentation sometime in the future on HA proxy, I think. It's really quite interesting. Anyway, it's a proxy. Connections come into HA proxy, and then they get fanned out to my servers inside my network. Everything coming into HA proxy is encrypted. Everything between HA proxy and my Apache servers, the way I've got this configured, it's not. This is a test server I've got. You can encrypt on both sides of HA proxy. But for this example, I can do that. Leave that up like that.
How'd you do back?
Three-finger swipe. So like I was pointing out, we watched the traffic there at that interface, and it's all encrypted, so there's really nothing to see. So I'm going to bring it up again, and I'm going to watch the traffic at this interface. Of course I can't. So let's do that again. And instead of doing it on ETH0, we're going to watch on L0 or LO. Let's put it to O. This time we're going to watch. Now I'm not using port 80 between the two. I'm using port 5081 just because that's how I have it set up. Actually, before I do that, let's go back to. I'm going to log out and get back to the login prompt. Come on. So that, get back to the login prompt. Okay, we're back to the login prompt. I'm going to start capturing packets. So we got 38 packets that time. Go back to Wireshark. TCP, J1, TCPDUMP, what do I call it? PCAP. Look at that one. Now, just throw these columns up. And now we can see, you know, there's no TLS, there's no SSL. It's just either plain old it's either TCP or HTTP. Right, I've got only a couple of HTTP packets, so let's go take a look at the first one. And here, if you look at these bytes, you can see there's some real data, right? Somewhere down in here. You can even see my password, right? Username, JAM, login password, and I created a special password for tonight. Capital P4SSWORD, that's my password. But what's really cool about Wireshark is this pane in the middle. It will break it out for me.
Oh.
Does it look for like keywords and stuff?
What's that?
Does it look for like keywords and things to break it up like that, or based on the syntax?
No, it
of
understands the
packet?
HTTP protocol.
Okay.
Yeah, that's the actual text running across there.
Yeah, it actually understands the HTTP protocol. Now, along with it, what I'm glossing over is things like the Ethernet frame, all the Ethernet stuff, some more Ethernet stuff, the IP protocol header stuff. What's neat, remember I was talking about TFTP when I had to decode the TFTP stream and look at the RFC about how to do it and figure out which bits did what. Well, Wireshark does all that stuff for me. And what's really neat is it's much better on a larger screen, trust me. But things like the source IP address or the Internet Protocol stuff. So the Internet Protocol, the overhead for IP, when I click on Internet Protocol, it highlights those bytes that are the IP header, right? And what is it, 20 bytes that are an IP header? And so that's 16, 17, 18, 19, 20. So that 20 bytes is the IP header if you're interested in that kind of stuff. If I collapse that and I look at the TCP stuff, there's the TCP header stuff that comes after the IP. Yeah, click on that, it kind of shows me all the TCP stuff. And, you know, the source port, it breaks that all down for me. And I get down into the HTTP and it shows me like the headers and stuff. And this is really nice for breaking apart that whole stream of data. But when we get down into the HTML that was there, you can see that session was not encrypted, and there's my password, clear as day. This is kind of the reason why people use SSH now instead of Telnet, or SCP or SFTP instead of FTP, because somebody could get on that network, capture that packet trace, and read, you know, in plain ASCII, your password or other, you know, important information. Right? How many still use Telnet?
What?
Nobody. Few.
There are devices that only allow.
Yeah, sometimes
Well,
you get
set up and stuff.
sometimes you get a router you have to Telnet into, or you get a. I mean, hopefully you don't have routers facing.
I Telnet to port
facing the
25.
road. Sorry.
So-
I've Telnet to port
Yeah,
25.
Yeah, Telnet. you know, I telnet to port 80 to check out an Apache server to see if it's responding. You telnet into port 25 to check an email server.
Right.
Yes,
You know, stuff like that. But, you know, hopefully you're not using telnet every day to log into servers and do critical things.
No.
The only time I telnet is that there's a server that out in the world somewhere that if you telnet into it, it actually plays like the first 5 minutes of Star Wars all in ASCII.
Yeah, an ASCII version of Star Wars, yeah. Yeah. How many people are still using FTP?
Well, I got customers that do.
Same here.
Yeah, they
There's
just,
no password protection on that,
no.
right? I mean, yes, there's a password on it, but, you know, somebody snooping on the net, they can watch that.
But you can do FTP over SSL.
I'm sorry?
You can do FTP over SSL.
Yeah, you can do secure
That's
FTP.
FTP.
There's FTP over SSH, which is SFTP, and then there's
FTPS, which is.
FTPS. There's various versions of a secure kind of FTP. Yeah, hopefully, you know, I still use FTP occasionally, but it's usually going out to a site to do a download where you log in as anonymous.
Oh.
You know, I'm not too worried about those kinds of things. Nobody's going to see my password. My password, for those, you log in as anonymous and your email address is your password.
Right.
And they don't even check that. But you can see how using TCPDUMP, you can snoop on the network. And, you know, it's a little tough with the screen size I have and showing it, but it's, I don't want to get into too much into Tony's stuff. He has to be very efficient.
It's okay. If you want
Just
to
to
talk.
go back to the command line TCPDUMP,
Yeah.
as I recall, can't you also give it things like number of packets to capture or file size?
Yeah, you can do a dash C, dash lowercase c to give it a count of how many packets you want to get. So maybe, you know, you just want to get the first 100 packets that come across the wire. The filter language, you can specify all kinds of filtering stuff, so you really narrow down exactly what you're looking for.
If you set a file size, does it just break it and create a new file?
You can
next
set
to
a,
it?
you can set a, I think that's capital C, you can give it a file size, say 100K, and it'll create a dump file of 100K, and then once it goes to write the next packet that's bigger than 100K, it will close that file and open up a new file, incrementing, I think, a number on the end of the file name. So it'll keep creating these packet dumps sequentially, you know, for as long as you want. The man page on TCPDUMP,
You just need a P.
TCPDUMP. It's pretty extensive. It's, you know, it tells you all about all the options and stuff. You can give it options to get more or less data. So that's pretty good. But the real good one, there's another man page that you might want to look at. Here it shows how you can, you know, do some filters, but it'll be down here at the bottom. What's the name of the? I'm looking for the C also. Where's PCAP filter? So this discusses that packet filter syntax. You know, so I did basically I just did port. I think I did destination port 80. But this PCAP-filter man page is the one you really want to look at to figure out how to do your filtering. DIR is the direction, whether you want the source or you want to get packets going towards the source, or towards the destination, coming from going towards the remote machine, coming from the remote machine, or going both directions. Protocol, so you can tell it I only want to look at IP, I only want to look at IP6, version 6. I want to see ARP packets. Here's some simple examples: destination host, and then either the IP address or the host name. That would be only show me packets that are going to that host, and source would be only show me packets that are coming from that host. can do port range. Yeah. Lots and lots of stuff you can filter on. And you can see how, boy, spending, go poke around the RFCs sometime on that RFC website and see all the you know, the little bits of all the protocols, and you'll really begin to appreciate Wireshark, what that does for you to break things apart. Let's see. I think that's what I wanted to cover. Are there any questions on this? Yeah.
I worked many years with colleagues who encouraged me to always dump TCPDUMP and then use Wireshark for interpretation, under the theory that Wireshark's formatters might have bugs in them or even malware and that great nasty code. So you're better off using the simplest code that you can under.
I think deep down it's using the same simple code to actually capture the packets. It's using lib PCAP. But you know, for me, it's just I'm never at the machine where the you know the network stuff is happening on. I'm always remote somewhere. So I SSH in, use TCPDUMP to grab the packets, and then just use Wireshark to analyze it. I used to do an awful lot of support when I was doing LTSP. I did an awful lot of support, people all over the world, and they'd have trouble with, God, they'd have trouble with NFS, or they'd have trouble with TFTP, or BootP, or DHCP, and many times I'd get down to the point where I don't know what's wrong. Run this TCPDUMP command for me and send me the file. And you know, that always pointed out, you know, I would see things like, well, it's doing a DNS lookup and it's not getting back a response. I could see that in the packet trace. Things like, you know, Tony, I think you're going to talk about why is your download slow, or why is your connection slow? And many times I find that it's waiting. There's a 15-second gap between packets, or between something happening. There's a 15-second gap, and that's always a telltale indication that there's a problem with DNS. 15-second timeout. So Wireshark is great. It'll show you the timestamp. It'll show you, you know, how many milliseconds it took to get to each point, and then you're at, you know, 9-point-something seconds, and then it jumps to 24 seconds. There's my 15 seconds. There's a DNS problem. Very useful. Yeah, Kip.
So for diagnostics, does TCPDUMP provide error messages, the actual messages? Does Wireshark?
Well, TCPDUMP, the error message would be like problems with your invocation of TCPDUMP.
Yeah.
It's not going to tell you that there's something wrong with your network. It's really, many times I would use it to find out, is data flowing between these 2 points at all? Or not flowing. So I use, for our TCPDUMP, I don't even have to put it in hex or ASCII mode. I just want to watch the headers flow, you know, the IP headers. And if I see a bunch of data flying and I can see the source address is my machine and the destination address is the remote machine, data is flowing. Well, I know it, you know, my routing is good, data is flowing just fine. That's not a problem. If I don't see any data flowing, then I start to suspect there's something wrong with the route, there's something wrong with the gateway in between, there's something wrong with the other end. You know, the other end's not responding because maybe it's down. And TCPDUMP, you can watch that. You know, you can watch your client send out a connect request to the server, and the server never responds. And your client sends out another request. You can watch all this stuff with TCPDUMP. Very useful. And customers call up. They wonder why they can't get to Blue Cross for some reason. We do a lot now with online prescriptions, where you can submit prescriptions electronically. And for some reason, that online prescription site, SureScripts, once or twice a month, they're down. And you know, why can't I get prescription information? Well, TCPDUMP, and watch the traffic not flow. You know? I get to see that happen. Do you have a question?
No, not really a question. It's something we kind of use at work, just kind of building on this, where we're transitioning from TCPDUMP to Wireshark. Wireshark, is that Wireshark actually does produce a command line utility called T-Shark,
Yeah, they do.
which pretty much is just a thin layer over TCPDUMP and libPCAP, but what it allows you to do is it's the same thing as TCPDUMP, where you can dump packets down to a PCAP file or display them in your console, but instead of, because the TCPDUMP syntax for filtering and whatnot tends to be a little terse and kind of hard to remember.
Yeah.
And T-Shark actually allows you to use Wireshark's filtering syntax, which if you've been using a lot of Wireshark, tends to be a little bit more familiar, so you can set up stuff like TCP.port is this, IP.address is this, source address,
Yeah.
source address, so on and so forth.
Yeah.
We use it at work a lot, it's actually pretty cool.
Yeah, and Wireshark's got like a filter builder too, so you don't have to remember the syntax that you have to with TCP/dump. So that helps. I have used Wireshark on my local machine, sniffing the packets, but I don't find it as useful. And before Wireshark, that's not the original name of it. It used to be Ethereal. Anybody use it back then? Yeah, and then I'm talking 15 years ago. Yeah, I always called it Ethereal. Anyway, I think the kid that created it left the company. This has happened many, many times, right? The kid that made it was working for a company, and he left the company, and somehow the company retained the rights to the name, and he wanted to keep maintaining the project, so he forked his own project and gave it a different name. Anyway, more questions? Anybody? Tony?
Sure.
You ready?
Yeah, I'll plug in. And
All right, Tony's got all kinds of goodies to show us. I don't know what he's got
Hopefully
going on
it
here.
works. All right, so well, basically I have
Thanks, Jim.
So I have a switch down here, and nice thing about Cisco switches and probably most managed switches is that you could set what we call port monitoring, and you can take all the traffic from one port and then have it mirror out another port. So it's a legitimate way of sniffing all the traffic coming across either a specific port, or if that port is, say, the uplink to the router and out to the internet, then you can you start monitoring that port and you can see all the traffic going across. And so that's what I've done here is I have a really old Cisco switch, and there's a fan going bad, so I was going to pull it out, but it's not making noise now, so I just thought it'd be cool if I left it open.
It's nice and cool.
Yeah. Anyway, so I have my little wireless router set up, and it's Rainbow connection. So Rainbow is the Wi-Fi. If you want to participate in some of the demonstrations I'm going to give, Rainbow is the SSID, and connection, all lowercase, is the password. So basically what I'm going to do is mirror my desktop first. Maybe? Oh, there it is, mirror. All right, so as you can see up here, Rainbow and connection. That's the SSID if you want to pull on. So basically what I'm going to do is just a little overview of Wireshark. Some of the same captures that Jim was doing, or similar things, but on the local network. You know, some of the reasons why you might want to do it on your local network is that you're wondering whether, you know, if it's the PC just not connecting out, or not communicating at all, or whether it's something on the internet that's causing the problem. Now with the explosion of IoT devices, Internet of Targets, or, Internet of Things, you're not always sure what it's actually communicating to or doing. So if you're able to monitor all the traffic that's going through there and sort through, say, is it actually hitting, the Belkin website, or is it going off to some other ones, or what all is it doing? So this is a lot of the stuff that you can do. The other thing is, there was a couple researchers that was saying, we could tell Windows 10 is still connecting out even though you tell it not to update anymore. Well, this is how they do it. They set up a router or a switch where they can monitor all the traffic going through, and they suck it in with Wireshark, and then they start analyzing it. So if you start Wireshark by itself, like that, you can see that there's no interfaces. And this is Wireshark 2, so it's a little bit different than what you might be used to seeing. And you can see here that it can't pull any interfaces because permissions are denied. To be able to grab the interface in promiscuous mode, which means you want to be able to grab traffic that's destined for other PCs than yourself, then you have to run it in sudo or as root or in elevated permissions. And so now you can see here, now we have interfaces. So we have both ETH1 and WLAN 1. So I have both a wireless connection and a wired connection. The wired connection, you can see, is ETH1. That's actually what's the port monitoring is running. And the WLAN seems to be going crazy. I'm not sure what it's doing at the moment. Right. So what you can do is, if you want to just start a basic capture, say ETH1, and we're starting. So this is a lot of the same stuff that Jim was just showing. You can see it, but this is now in log. It's dumping it off to a temp file somewhere. It's not really saved at the moment. You can save it off and keep it for long term, but when you close it, it just closes. And you can see where all these IP addresses, we have source and destination addresses, and it's everything running across the wireless and the wired. Actually, currently nothing's really wired connected in, but I have my little netbook here on the wireless. My phone is connected on the wireless. But what you can do is now, if you start hitting applying filters up here, say we're just looking for HTTP. Now it's showing us just web traffic. Or say I want to say HTTP or you can't say and DNS because that's two protocols and it can't be the same thing. So you can say or, which is pipe DNS. So now we're seeing both DNS traffic and HTTP traffic. And you can see as some of the stuff for like the source address coming through, we have both, or most of it's the 1.1 because I'm monitoring the exit or the main port, the uplink. So I'm seeing everything from the router going out, but you can see some of the other addresses. Just basic, time.gov. So you can see one of the PCs, something's connected, is looking for a time update.
Attention library patrons. Would the owner of a silver Jeep Compass please come to the information desk? The owner of a silver Jeep Compass.
All right, so let's say we have enough. And this is just passively sitting here grabbing, see who's all connected. Now, if we want to go back and see one of those TCP or say HTTP streams, and as we scroll up and down, we can see there's Just not a whole lot here, because I didn't really go to any websites. Although something went out to a maps website. They're trying to get something related with map. Now what we can do is if you right click and go to follow, you can say follow this stream, and it actually brings up the HTML request in the field. And we can say the next stream down here, right down here at the bottom, and saying how many bytes are where. And then there's a lot of different filters, and that's what I was looking through. So you can filter on protocols like HTTP, DNS, FTP, Telnet. You can filter by the address. So say if you're interested in just anything coming and going from a specific PC, you can just say IP adder. IP.adder is that, and then grab, and then it'll show everything related to that computer. So let's say we're going to start another capture. Maybe. No, I probably have to close that capture. I don't want to save it. And we're going to start another one. So you see some of this stuff is in black. That's actually Wireshark saying, we know there's something wrong with these packets. And you can have it filter by that. So if you know if there's something broken off or not getting communicated right, you can start sorting through that.
Yeah, I thought it was usually like a checksum or something.
Right. So if we go to this is the HTTP site, and oh my map broke. But anyway, so we're going to see there's a lot of capturing going on related to this.
Yeah, that broke on the Mug website yesterday.
Yeah, MapQuest API changed, or yeah.
Yeah, I got it fixed.
So now we can.
You got it fixed?
Yeah, we can go through and start sorting by, IP address, like I was talking about. This is where it's saying you can do Boolean searching, where you can say one protocol or another. You don't want to say and. But there's other times where you want to say that. Or let's say we want everything but the stuff going on in the background. We don't want to see ARP or ICMP or DNS traffic. So you use the exclamation and it strips all that out. And now we're seeing other stuff. So somebody is connecting on the Dropbox with the IP of 102. We're seeing, some other stuff. So if we say follow this stream, that's a TLS. So this is going to be similar to what Jim was showing. But so what we would normally see as a web page now looks like garbly gone because it's an encrypted session. Although I saw one thing saying follow SSL stream.
You can do that if you have the keys for the. My understanding is you have to have the private key for the server.
Okay.
Private public key for the server, and if they're doing with the perfect forward sequencing.
Oh yeah. So you can see up here that when I was clicking on this stuff, the filter changed. Now it's saying this, you follow the stream. We're showing you just the stream that's stream 90.
You have a drop-down filter history, correct?
The what?
You can hit the drop-down and see your filter history, right?
Yeah, that is right here. Yeah. So we can go through and look at the different filters.
It's a little more user-friendly than TCPDUMP.
Yeah.
Right. You can also say, I just want to see where TCP is pulling it from, or where the person is grabbing the IP address. And that's where it knows the HTTP protocols. and it's saying just get the get requests. Or you can say get and posts. That's one of my other ones here. Get or. Yeah, because it's again, it can't be the same thing, so you can get or posts.
Can you pull the headers, just the headers?
I'm sure you can. I'm not sure. I know just enough to be dangerous.
And then you don't want to be able to pull specific headers, so that's handy.
Yeah.
Because what you just did, you probably can zoom in and look at the headers, but maybe you're interested in only packets that have a certain header.
Right. Yeah, you can see down here there's a few of the headers.
Yeah, the user agent header.
Yeah, user agent.
Yeah, it's all over, yeah.
You can also look for, say right here's a PNG file, and you're able to save that file off. I can't remember exactly where it is, but you can save the individual files, even if it's not, like right now we're running a live capture. You can save it from a PCAP file. You can save them out, so you can have the individual data still saved off. So if we stop this now, and we want to save it, so we say save as, it's going to create a .pcap file, right? Yeah. But you can also go through and set those right at the beginning before you start. So like, one of my questions was, can you set a specific file size? And in Wireshark, you can do that. In the options, we're saying make sure we're in miscus mode. And here, create a new file after. You can say 25 megabytes. Or you can say in how many seconds. So what's really nice about this in megabytes is when you're capturing traffic for a whole site, like a hospital, and you're wanting to know why a switch is going down or a connection to something is going down, you have to capture everything and then go back through and analyze it. So if you can break it up into megabyte sizes, otherwise if you let that run for a half hour, just because it might break in a half hour, you can end up with a 10 gig file, which will bomb your computer and you won't be able to open it. So this will split it up into smaller bytes. You can open individual ones. Wireshark will bring multiple files together, so you can then look at larger streams.
Tony?
Yeah.
So I'm just curious, if you're saying you can be watching for certain things, but it doesn't look like the tool actually does that for you. Can you set it to somehow trigger off an event when some particular type of packet comes through?
It's not an event. That's where the filters come in. Is you're looking for.
Yeah, it's not like a tripwire kind of a thing, event generating.
Right.
So I'm saying if an event occurs, can you take action on it?
What event?
Say a specific type of packet comes through.
Well, he
Well,
was
that's what the
filtering
filter
on
is.
port 80 and.
All right,
The
but
filter will say
so your
anytime-
point was, okay, so your point was that you have this megabytes of files coming through, you're waiting for something to happen, and then later on you have to go through and go that megabytes of file.
Yeah.
If there was something that said, this event has occurred, now I can capture some file.
Well, that's and there's pre-filters, so input filters or capture filters right here.
Well,
And
Tony,
so
your point was you don't know what's causing the crash. You have
Right.
to capture everything and then try to figure out where the crash is at.
Right.
And you don't
But
find the crash out.
Gibbs' situation is he's saying, something's going to happen. When this packet comes through, tell me. And that's where you can set the filter for that packet, in the capture packet.
Try to actually
But if what you want to do is say, I want to capture everything, and then when that comes through, then I want to look at everything just before and just after, then you leave this filter open, so you're capturing everything, and then you filter down to that event. So you can either do it by time-based, you say, I know 35 minutes in, this is what had happened. Now, I'm gonna pull back and, you know, scroll back and forth and see if something's happening right before or after that.
You're saying you can chop up a file that's too big and rejoin it later.
Yeah. Yeah,
That'd
so,
be nice to see.
I'm sorry?
That'd be nice to see.
I'm sure.
I don't think there's anything special about the PCAP files, it's just a stream of data, and I think you can just cat them together.
Pretty much. Yeah, well, actually, there's some headers and stuff in the PCAP files.
Yeah.
I tried breaking one up because I forgot to set this filter, and Wireshark didn't like it. It said it was an invalid PCAP file. Yeah.
What's the PCAP NG?
Next generation?
Yeah, I would assume. I don't know. But here, yeah, let's do.
Maybe impacted it something else as well.
Alright, what am I? Let's see here. Choose an interface. Start. Oh, that's funny, because I'm running as root. Or- Right, so I can save those files, yeah, so,
Yeah, I just upload it down. TMPT.
so we're seeing stuff come through. What's a large file?
Bring up a YouTube video.
Yeah, because I'm splitting into 1 meg bits. Oh. The other thing we can do, actually, this is what I want to show is FileZilla. I'm going to FTP a file up to the server I've connected. So now I'm connected. And so what we're going to do is look at the PCAP, and you're going to see that I have, we'll be able to see that using the password. So my Wireshark notes, we're going to say uploaded. You can look over here, and we can see the files here now. Let's see, can I upload something a little bit bigger? I don't know. I don't want to upload an ISO, that would take forever. But, you know, something multiple.
Well, that Oracle file is only 17 meg.
Yeah. There we go. So now if we go in and
1 second.
Plus longer.
Wow.
Yeah, no, I saw that too when it flew by. It's like,
Well, even nice.
what is it? I must not save it. Well, no, I thought it saved it as we're running.
Yeah, you did, it's a test form.
Uploading over the wireless instead of M1.
that's what PCAP file is like.
Well, either way, it should still be capturing it. Yeah, but we should have multiple files.
Oh, it's at 712 in 1948. That's now third file from the bottom. Yep.
Yeah.
But that's just, yeah, there should be 17 of those at least.
You know, 401 and then 402 and then 403.
Well, check it. Check it.
So if we want to say, like, go back and say, just look at FTP traffic. Oh, it's not. You're right.
Was that wrong interface?
No, I want to be capturing on the WLAN interface because I want to capture everything running through there. So the port monitoring might not be working right. So we can stop this. We'll do the same thing again, but change it to the WLAN. And WLAN, let's double check we still have, so WLAN output will still be, let's call this 2, whereas 1 megabyte, 100K, and then start. So I'm going to disconnect from my FTP and reconnect. And we'll throw it up there again. Well,
Oh, you can have a lot of files if you do that.
so it's going to overwrite. So now if we go in, to be honest, I've done this on my work laptop, but not here. So it shows the 2, but still, I don't know why it's not giving us multiple test tube files.
If they do an LS minus A, or minus L.
This is why I never do live demo.
Yeah,
Right.
32K was the one, the other was only 7K, so. Well, it doesn't actually, it wouldn't actually put the data though into the Wireshark log. I mean, there's a command to say FTP this file. So you're gonna see every packet, is that what you expect to see?
Yeah, you're supposed to.
Are you, or are you just doing the?
Are you just grabbing the first 64 bytes? Wireshark would get the whole thing.
It should.
Like TCPDUMP will only grab the first 56 or something.
Oh.
Unless you tell it.
So if we go back here. Oh, you know what the other thing is? When it does start splitting it out, it only shows you the current file you're looking at, not like past the future. That's where you have to start sticking together. But you can see up here that my username and password is showing right here.
Yeah.
And the password is password 1234.
Ooh, that's secure.
See, it just cleared out
So
because it
probably
created
close
a
the
new file.
and the new one.
Yeah, so there, now it shows 2 of them. So now if we stop and clear that out, so if we say file close, now we want to open, say, our first PCAP. And I say, show me FTP. But say, well, you know, there was something else there that I wanted to grab. So we can say merge with file 2, which is only 2K, but now it's showing us both. Yeah. So let's say, just show me DNS traffic, you know, or DNS or FTP. There's a lot of other filters. You can, where is that? What was I saying, that you can see if there's errors in the TCP packets? You can say TCP analyze flags. So we say, now this will tell us just, you know, errors in the flags for the TCP strings. You know, there's X and peopleize. So I mean, something was trying to connect out and was you know, either keeping the connection running, retransmission, meaning that I didn't get a accurate acknowledgement, so I'm retransmitting. So this is really down to the, the protocol level work, not just seeing a few things. So let's go back. Let's say and follow stream. So this will tell us, the right at the beginning, is the FTP communication back and forth. We never saw any of that when I connected. So if you're interested in whether, what you're connecting to, what's the protocols.
Well, yeah, because you're
All
using a
sorts of stuff.
GUI FTP client.
Exactly. Yeah, and maybe what it is that, say if you have a customer that's using some random FTP client that you don't know anything about, and you're saying, well, are they connecting with ASCII or binary or this or that? You can start capturing some of the stream because they don't know any of this stuff. You can start capturing the stream and then go through and analyze it and find some of that info. Same thing with doing updates on your computer. That maybe Windows updates should be running, but should Java updates be running? And you told it to close, but is it running in the background? You can start capturing this and say, is anything going to update.java.com? You can also go through, and I think maybe give this maybe a little bit of what you're probably going for. You can check to see if the TCP connection, if there's actually what text is in the connection. So, say we're not sure if they're using HTTP or FTP, but if we say if the TCP contains username, or user.
Contains, the word contains, software.
So, right here we're looking at in this packet, something shows user in here.
Yeah, so that's half of it. And the question is, that just goes to a file and you have the ability to search on it and stuff rather than. So, the concept is you want to be watching for something. When that occurs, then you want to somehow flag the records around it, right?
Well, there are ways to do it, and more on a corporate level, there's more captured appliances. Riverbed sells equipment that does this, and what it does is it sits there and watches your internet traffic all the time, and you have terabytes on terabytes and terabytes of data, and it's always shoving all this data. So every user connection going out, everything going in and out, and that same appliance has the SSL certs acting as a proxy, and so your PC, you have to install that cert on the PC. So it's going through and breaking that SSL connection, take a look at it, and then makes the connection back out to the internet. But as it takes a look at it, it throws it off to a file. So now what can happen is the security team can say, we know there were some events, our SIM tells us there was events yesterday at 5 o'clock. And then they go to the network team saying, now I want you to pull up the packet captures from yesterday at 5 and 5 minutes before that, so we can see where they start the connection coming in or getting out. So it's possible what you're asking for, but not just with Wireshark. It's multiple appliances, multiple systems will do that. So you need one system that will watch for the events coming in and out. You need another system that's capturing the data. Then you need another system that you can analyze the data with. When you're looking for something large scale, like corporations have, then that's where you need appliances that can do this. The Riverbed steel-belted or steelhead devices actually have Wireshark built into it, because Riverbed is the corporate sponsor for Wireshark. So what they can do is you can have it do like basic filtering right in the web interface, and then if you're not getting what you want, you can download that PCAP, just say download, and it opens up in Wireshark that's on your PC, and you can start sorting through it.
Yeah, and Wireshark will run on Windows as well.
Right, yeah, and that's actually where the most of my use has been on Windows. And everything I've been showing you is in, this is Wireshark 2. And the Windows version, Wireshark 2, has a legacy mode. So if you don't like this view or you're used to the old mode, you can open it in the legacy mode. And this may have it, I just don't know where it's at.
The basic user interface is very similar between 1 and 2.
Right.
The different panels.
The
right,
3
yeah.
panels and the.
Yeah.
Yeah, this stuff right here is the same. It's the
How do you do
toolbars
your
at the top.
filtering?
And when you first open, what are you seeing? You know, this stuff.
Your launch screen.
That's
Right.
really cool. Makes it pretty simple.
Yeah.
Now, oh wait, maybe it was under recent. There is a,
Hmm?
That makes me want to do more network.
Yeah. Yeah, 'cause it's a nice tool. Very nice tool.
Yeah. It's always, ever since I learned about it,
Toolbox.
where did I save it? Oh, you know what, it's just my downloads.
Then there's, the analyze.
You can download, if you want to do test practice and you don't know some of this to do, you can download some of these PCAPs right from the Wireshark website. And what is this one? I thought I called it SIP, but oh yeah. You can go through and you know, say, you know, if I filter for this, should I be seeing one thing or another? I had a SIP stream earlier. Where is it? Oh, it's Wiki now. Sample captures. And what's really cool about Wireshark is you can do you can take the data and analyze it and then bring it into
That open in Wireshark?
yeah, it just, this is the packet I just opened up. But you're able to pull in, like SIP, a SIP call is a IP phone protocol. And so SIP is the connection communications. And then RTP, I think it's RTP, is the actual data stream. That's a UDP stream. And what it'll do is it'll decode that RTP stream into actual audio. And you can listen to the phone call. And so I've done that at work, and for obvious reasons I can't bring that one in. It'll be sort of for us to listen to that stuff. Oh, here we go. So you can see here we have some SIP protocol data and some UDP. So if we say SIP, it'll just give us the connection info. You know, the to and from. We say follow stream. This is giving us the communication between the two server, or the server and the phone. You know, it's going to verso.com. If we say SIP or RTP, and then it's just showing us the two of those. Now, what's also cool is, say, I'm not really good at finding which packet we need to follow stream on what. There's telephony tools in here. And we can go down to SIP flows, and this shows us the different connections going in and out. And is it this one? You could say play streams. So this one doesn't have any data in it.
shooter method.
In RTP packets that play the stream.
Huh?
Don't you need RTP stream, not a SIP stream?
Well,
the audio?
but that's what in the telephony, it'll bring it up. And it might be because this is a, yeah, here we go. And it gives you the waveforms of the call. And let's see, yesterday when I was testing this, yeah, for some reason it's not actually playing for me. I don't know whether it's a configuration or something on my computer. But it will actually play that conversation. And you can mute one side or the other. You can split them up. You know, so this shows you one person talking and the other person talking.
Yeah.
On the first version, it was like a two-step process to get to here, but on this version, it brings it all up in one. You hit just play.
Are those seconds below that? Like how many seconds into the call?
Yeah. Well, it's seconds into the stream. So if you look at the timestamps on Wireshark, it's not the timestamp of what time it is. It's how long since you started that capture. And it also gives a serial number to each packet. So you can go packet by packet and see what's going on. And so that's where it's important to take notes while you're doing packet captures. Because you can say, you know, it was 7:30, but did I start the capture at 6:20 or 6:40? So now all of a sudden you have to search in a 20-minute time span. So if you take notes of the exact time you start, then you can correlate that with the timestamps. Huh?
You have to go 3 steps forward and 2 backward all the time.
Right. We haven't gotten the message that the internet's going to shut down, so
No, you
we might have a few more minutes.
20 minutes before that happens.
Okay. Let's see. Yeah, so down here, VoIP, so you can do sorts just like I was showing, SIP, RTP, or SIP and RTP, but it should be SIP or, SIP or. If you want to see if you have a SYN flood coming in, somebody's attacking your server, then you can sort by SYN packets and say, just show me if there's one of them. Then if there's not a conversation happening, or it'll show you the SYN packets. The exclamation before is the not. So it'll do both. Is it most Boolean searches, I believe? Or is it just and or? But you can start combining them by putting them in brackets. So you can say, don't show me this, and then you can add on, and show me only HTTP. That may not make sense, but you can start combining searches like that. You can show me by the IP address, and specific protocols.
If you want to learn about networking, it's a great way to watch the whole connection thing happen.
Right.
Especially for simple protocols like Telnet or
Right, yeah, so that's where, if you're seeing, what we're showing here is you can see these plain text passwords and usernames. Don't use, insecure protocols, FTP. You want to use SFTP or something secure, where it makes the secure connections. Same thing with going to websites. If you have an option to go to HTTP, or HTTPS, you want to go to the S site.
Only if you're logging in.
Huh?
Only if you're logging in.
I don't know, it depends. Yeah, it depends on who
I don't know, you go to
you're
a shopping
worried
site,
about
you're looking
watching
for
what you're
something,
doing.
and then now for the next 5 weeks you get ads. That thing you were watching, you didn't
You're
have to
gonna
log
get
in.
ads anyways, because it's usually the site itself that's bombarding you with ads.
If it's encrypted, I don't know
Most of the sites I go to are encrypted, and I get
Logging
them.
into the sites like Google or Yahoo, are they encrypted?
They are now. They
They are
hadn't
now.
been for a long time, but
Okay.
they are now.
a lot of them are forcing you to be in.
Yeah, Facebook
Like
and
Gmail for a long time
Gmail.
had a choice, and Yahoo had a choice.
Or even Google,
Right.
but your searches.
Well, also the web browsers are forcing you to, right?
No, it's not the browser itself.
The
It's
browser will let you connect whatever you want to connect.
It's just doing what the server tells it to do.
Right.
The browser, if you
What-
connect to a site,
There's
secure.
There's plugins
But
that you
it's
can
broken.
run that, like HTTPS Everywhere is a plugin for Chrome, and I'm sure there's one for Firefox. But what that'll do is when you go to connect to a website, it'll check to see if there's a HTTPS version and connect you to that instead. There's all sorts of things, but you also need to remember that if you're on a corporate LAN, you're on your work computer, it's their computer, so you shouldn't be doing bad things on it. If they catch you doing stuff,
Yeah, tonight's meeting is for presentation, for
That's right.
educational use only.
Yes.
right.
Home use.
But the other thing I was saying, even with the proxy appliances, they're even your HTTPS sessions, they're breaking that open and they can read it. So they can read your personal emails.
Yeah, they're bringing up their own certificates that are.
That's right. Well, they just, what they do is they make their own CA within the company. And then it says, respect everything that my CA creates, all those certs. They put that on the proxy, that cert on the proxy, and then now all of a sudden it'll accept and doesn't even tell you. Unless you have something else put in place to tell you that you're connecting to, or the cert is not one thing, or the Facebook is something else. Yeah. So that's why it's important not to do banking in places you don't trust. Even at Starbucks, where they're probably not going to have it, where they're going to crack it open. But what if there's a hacker that happened to get that leaked cert from Veritas or VeriSign, and then all of a sudden they can crack open all of your secure connections. So it's just it's important to be vigilant in what you're doing. I don't know what else to say. So
Use
Yeah.
VPN and unsecured applications.
right. No more questions or anything? All right.
All right, excellent.